Now, so far, we looked at a few cases. The simplest one, where you just subtract them from point A to point B. Second one, enclosed areas, you may have to find the intersection point. And the third one, you have multiple enclosed areas, in which case you take the absolute value and you split the integral. And now we're going to look at another case, which is slightly more complicated. I'm going to call it the case where we use horizontal rectangles. Let's say you're trying to find the area enclosed by the line y equals x minus 1 and y square equals 2x plus 6. When you plot this is what you get. Now, even before you go ahead and try to find these points, you notice that in the region A, right here, this part, the top and the bottom functions are the same. And in region B, the top and the bottom functions are different. That's a problem because that means I'm going to have to split this and then use two different branches of the same function as my definitions, right? So if we have to use a regular method, we have to split the integral and it becomes really complicated. Instead, what we note is that if instead of moving up to down, we move left to right, the boundaries lie on unique curves, right? If I move this way, I notice that my left end point is always on the blue curve and my right end point is always on the purple. So this is a motivation to consider using horizontal rectangles to approximate the area. Because really, if you are approximating this area, you can also do it by slicing it horizontally, right? Or you could approximate using vertical. So both of them are equal. Now this requires us to find x in terms of y. Now here's a concept check. You can fill in this blank. Interchanging x and y is a process of what? Now for the right one, x equals y plus 1, and for the left one, x equals y squared minus 6 over 2. So now this is called, we call this integrating with respect to y instead of x. Because now we are forming the rectangles on the y-axis, we need to find the y-coordinate of these points. So we set them equal, ends up being a quadratic. We get two of these values. So we know this here is y equals -2, and this here is y equals 4. So my integration is -2 to 4, right function minus the left function, which you solve out and you get them to be 18. Okay, so for the same graph, or if you have two functions, you're going from x equals a to x equals b, and if you're using vertical rectangles, that's called integration with respect to x. Because your bounds are x equals a to x equals b, and you have f of x minus g of x dx. But if your case is something like that, and you're using y equals a and y equals b, then you want to use vertical or horizontal rectangles. And this method is called integration with respect to y. And that's because this is going from y equals a to y equals b, and it's f of y minus g of y dy. Okay, so these have to be y terms and these have to be x terms. So that's it. And then you have the worksheet, which I'll post another video about the worksheet.